So in the last class, we have seen the signal classification based on one-dimensional or multi-dimensional, and then followed by continuous or discrete signals, and then analog and digital signals. And then even and odd signals. Okay. Now in this class, we will be focusing on some other categories like deterministic and random signals, periodic and aperiodic signals, and energy and power signals. Okay. So when a signal is exhibiting some behavior, okay, uh, and that can be formulated or represented mathematically, then such signal is said to be deterministic in nature. Okay, so if a signal exhibiting a pattern or a behavior, and that can be given or can be represented by a mathematical equation, then it is said to be a deterministic signal. Or otherwise, the signal is not having any characterization, or it's characterized by uncertainty. See, uncertainty, that means you don't know what will be the value of the signal at some instant t equal to 3, t equal to 5, or t equal to 0.5 seconds. Okay, then it is said to be behaving randomly. Okay, so you don't know, you cannot estimate the amplitudes of these signals. Then such signals are called as random signals or non-deterministic signals. Random signals are non-deterministic signals. The thing that you have to know is random signals cannot be described by a mathematical equation, wherein you require processes to describe how they behave, and by which you can estimate or you can find out the probability. Okay, so this is the case with the random signals. So here you can see the examples of a deterministic signal. It seems to be a sinusoidal signal, and you can represent that one mathematically like this sine, okay, omega t. Simply I can write sine omega t. Okay, so what happens is it forms a sinusoidal pattern for different values of omega and t. Is it not? Or simply it is basically a function of sine theta. Okay, so like that, if it behaves okay as per the sine function or cos function, all such signals are said to be deterministic in nature or deterministic signals. Okay, whereas you can see here the signal at the bottom, it is not having any pattern, and you cannot say it is having a regular pattern, and by which you can identify the coming instance. Okay, so it is behaving uncertainly. Okay, so this particular signal is said to be random or non-deterministic signal. Okay, is it clear? Any doubt regarding this? Any doubt? Right. The next category is periodic and aperiodic signals. If any signal satisfies this particular condition, x of t is equal to x of t plus or minus mt. X of t plus or minus mt. See, t is the independent variable time for the signal x. Okay. So for some capital T, okay, it is behaving in some pattern. Say it is behaving like this up to this particular T, capital T. Okay. So now after this T, once again this is behaving like this exactly, right? This is for the next T, capital T amount of time. Okay, capital T is the amount of time or duration of time for which we are looking at the signal. Okay, then what happens is, if you see after T plus capital T, say you make it 1. Okay, T plus capital T, that means we are at this point. Then this point and this point are same. I will use another color so that you'll have a better identification. Yeah, this point, now x of t is this one. Then what is x of t plus 1 capital T, x of t plus 1 capital T, this one. Okay, similarly you make a small t equal to 2. This is small t, x-axis is small t. Okay, so 2, this is the instant, this is the amplitude. Okay, 2 plus 1 capital T. Then what happens? 2 plus 1 capital T means you have to move in this the same amount of time t. That means this one. And now you look at the amplitude. The amplitude. If this amplitude is equal to the x of t, then this particular signal is said to be periodic. Okay. So what actually this particular periodicity says is this particular signal behaves in a deterministic way, and it resembles a pattern, and these patterns are continuous, and uh, so these are repetitive in nature, and you have to find out the periodicity. Okay, when these regular patterns are behaving, repeating. Okay, so that capital T amount of time, after which once again the cycle is repetitive. Okay, cycle is repetitive here. Okay, this capital T is called as periodicity. This capital T is said to be periodicity. Okay, and we have taken only on the positive side x of t plus capital T. We can do also on the negative side x of t minus t capital T. Okay, suppose if this condition is not satisfied, it is said to be a periodic signal. It is said to be a periodic signal. Okay, what is this fundamental time period? Just now we discussed this smallest value of capital T, which satisfies this equation, above equation, is called as fundamental time period. So the period may be fractional and integer. This period can be fractional or integer. So in order to have an identification, the good examples for periodic signals are cos and sine signals. Cos t like this. Okay, sine t is another periodic signal with the periodicity 2 pi. So it will start here. Okay, sine signal, cos signal. So you can see the patterns are repetitive, and where the period is 2 pi. Is it not? You all know that 0 to 2 pi, and once again from 2 pi it is repetitive. Okay, this 2 pi sine 0 is equivalent to sine 2 pi, and after once again it will start from that point. Okay, so you'll be having that regular pattern here coming, which will be equal to the nature what we have up to 2 pi, 0 to 2 pi. Okay, similarly the case with cos t also. Okay, this is about periodic signal. So the thing that you have to remember is uh, the periodic signal has to satisfy this condition, x of t equal to x of t plus or minus mt, right? Yeah. So now you can see a signal is shown here. This is t naught. Okay, this is the smallest possible value of time t, amount of time t or capital T or capital T naught, uh, which satisfies this periodic condition equation. Then this t naught becomes the fundamental time period, right? And this is for continuous case. Similarly, we can handle for a discrete case. In discrete case, what happens is the signal will be like this. See here. it is at n equal to 1, n equal to 2, n equal to 3, n equal to 4. Okay, these are different instants, discrete. Okay, I hope you all still remember what is discrete time signal. Okay, now at n equal to 5, I have the signal like this. Do you got it now? It is 1, 2, 3, 4, 5, 6, n equal to 6, n equal to 7, n equal to 8. So now if you look at the first n equal to 4, okay, n equal to 4, the amplitudes are like this, decreasing, and in a similar way from 5 to 8 also they are decreasing. That means it is following a regular pattern after 4 instants. Okay, so now the condition that you can show here is x of n equal to x of n plus capital N. So once again this capital N and this capital N uh, determines the fundamental time period for this sequence. Okay, it is simply called as period. Okay, and you have to see that it is a strictly positive integer constant n. It is a strictly positive integer constant. Okay, and once you have this period and take that you have an n periodic sequence x is set to have frequency 1 by n and angular frequency of 2 by n. Okay, similarly for the previous continuous signal also, a continuous time signal which is having time period of t will have a frequency of 1 by t. I hope you all know this from your intermediate physics. Okay, f equal to 1 by t. Okay, and having an angular frequency of omega equal to 2 pi f, is it not? Okay, or I can write 2 pi by t, anything is okay, right? Okay, so this is the definition for periodic sequence of frequency and angular frequency, and the bottom one is for continuous time case. So if it is not satisfying this equation, any periodic any sequence is not obeying this equation, then it is said to be aperiodic in nature. Okay, so you can see the signals here, periodic signals. Still it is behaving in a regular pattern. See here these waveforms. Okay, here also. Okay, right. Now you can see here 0, 1, 2, 3. It is increasing. The amplitude is like 1, 2, 3, 4, and from 4 onwards, once again the amplitude is 1, 2, 3, 4. Okay, it is following a regular pattern in this sequence. Yeah, these are aperiodic signals. Okay. Now the point is you'll be given a signal and you're supposed to calculate or want to know the periodicity of that signal. Or in some cases supposed to calculate or to know whether the signal is periodic or aperiodic. Right. So suppose that two signals are given, x1 of t and x2 of t. Right. And these two signals are periodic with the time t1 and t2. Okay, then if a signal y of t is formed as a combination or as